Hello all, this is Nishu Agarwal from Thapar University Patila. I have developed Prosodically guided phonetic engine for Punjabi language under the guidance of Dr. R.K. Sharma. I have done this work for 30 phonemes as well as 34 phonemes. The recognition process has been done using HTK in Ubuntu Linux Environment. The same work has also been simulated using Java. So, I am going to display the process I have followed to develop this engine. First of all, we slice the audio file into the segments that does not exceed 5 seconds duration. In a folder named as wave, we store all these files. In the second step, we divide these files into ratio of 75% and 25% because we are using 75% of data for training and 25% of data for testing. That is why we create two separate folders, named as training_wave and testing_wave. After the process of separation of files, we transcribe the speech by using the standard IPA chart, which creates a text file that contains file name and its corresponding transcriptions. These transcriptions helps to create MLF file. To create MLF file, we pre-process the transcription file, which includes the separation of silence and correcting place of diacritics. This pre-processing results a text file named as trans space after final. This file contains the file name of audio signal with .lab extension and corresponding phonemes with separation. To train the phonetic engine, we're developing the HMM model for the phonemes, which needs several configuration files like analysis configuration, analysis train configuration, dictionary, grammar, HMM list and list. Analysis configuration and analysis train configuration contains the configuration which is used by HTK to train the HMM models for phonemes. These configuration contains the value of source format, source kind, samplifier, window size, etc. Dictionary file contains the phonemes used and their corresponding sounds. Grammar file contains the regular expression that concludes the phonemes. HMM list file contains the phonemes for which we are developing the HMM models. List file consists different phonemes with diacritics and their corresponding ASCII symbols. As we know that our digital machine understands only ASCII codes and we have the transcription in IPA format, so there is a need to convert these IPA symbols to the corresponding ASCII symbols. For this purpose, a conversion script has been written which does this conversion process with the help of list file. After executing this conversion script, we get a text file named as trans ASCII that includes the audio file name and their corresponding transcriptions in ASCII format. Many times it happens that some symbols are left to convert, so we need to find these symbols manually and convert them to corresponding ASCII format. After all these conversions, we prepare a file named as trans ASCII1. At this step we need two more configuration files, that is proto and mixture1 head. These files store the information about the working of states used to develop the HMM models like mean, variance, and transition. Mixture1 head file contains the phonemes and their inclusion on the non-emitting states. To process the wave files, we need to calculate the feature vectors. In this work we have chosen MFCC as a feature extraction technique because it is logarithmically aligned and best suitable to human auditory system. To measure the MFCC features, we prepare a file named as target.list that contains the path of audio wave files as source and path of MFCC files as destination. For this purpose we have used hcopy command. At this point we have transcriptions as well as MFCC feature vectors. To train the phonetic engine, trans ASCII file has been divided into two parts named as train.mlf and test.mlf in the ratio of 75% and 25%. Now we use our shell script that contains the code to use hcomp, head and hrest tools of HTK to train the phonetic engine. Here we have used 32 Gaussian mixtures for 30 phonemes and 36 Gaussian mixtures for 34 phonemes. After completion of training, we use hparse tool of HTK to create WordNet. Now for recognition we use our audio files and their feature vectors and this WordNet file. Now we execute our test script that consists of iter-b algorithm to recognize the unknown utterances of speech according to trained phonetic engine and feature vectors. Test script also generate a confusion matrix that compares the result of computed transcription and manual transcription in terms of phonemes placed for a particular utterance. The results are there on your screen.